Well, good evening, everybody. Welcome to our live moon tour. This is the seventh in hopefully an unending series of moon tours that we're going to do in perpetuity, we hope. My name is Kevin Mace. I'm a member of our outreach team here at the Frank N. Bash Visitor Center at McDonald Observatory. Now, the observatory is a research branch of the Department of Astronomy at UT Austin, but we're not located in Austin. We're actually located very far out in West Texas. I'll show you some beautiful pictures of our site here in just a minute. Again, I wanted to welcome all of you this evening. I wanted to mention also that if you have a question during the program tonight, we do have some moderators that are looking at the comments as they come in the chat window. And so don't wait until the last minute. If you have a question that you would like to ask tonight, do submit it to our moderators during the program. And those moderators, I wanted to thank them. They're doing an important job for me. And toward the end of the program, they're going to be sending me some questions from you guys for me to answer at the end of our program tonight. I also did want to mention that we plan to have another program similar to this one, not so much featuring the moon, but featuring a bunch of planets. In fact, we're calling this program the Planet Fest. This will occur roughly in a month or so. We don't have the exact date pinned down yet, but in about a month or so, Mars is going to be at its closest point to us in quite some time, and so Mars will be very visible in the evening sky, in addition to still having Jupiter and Saturn, which we also will be viewing tonight. So do stay tuned, keep an eye on our social media channel, and also our website here for the Visitor Center, and we'll post updates on there as soon as we have them. I also did want to mention that the Visitor Center is now open for visitors. We're open in a very limited way right now just for star parties, just for a small number of people for star parties. Now, the bad news there is the star parties are sold out at this point through the end of the year, but we do hope to be adding some more capacity to these programs in the near future, and we'll bump up the reservation number, so do keep an eye on our website and watch for that. Also, we do hope to begin our daytime programs again, our limited access guided tours. We do hope to start those up in a few weeks as well. So we do have some good things coming up for you. And again, thank you all for being here tonight. I wanted to show you our location, where I am located right now. I'm on campus here at the McDonald Observatory. This video here shows the summit of Mount Locke, the highest point on our campus here, and then two large telescopes near the top, at the top of that mountain. The one on the left there is the original telescope, the 82-inch Otto Struve telescope, which was dedicated in May of 1939, and it was the second largest telescope in the world at the time. The other large dome there, the one on the right on the summit of Mount Locke, is the 107-inch telescope, the Harlan J. Smith telescope, which was dedicated in November of 1968, at which time it was the third largest telescope in the world. And then the other peak over there in the background that you see in the video, that is called Mount Fulks, on which sits the 10-meter or 394-inch Hobby Eberly telescope. That is our newest and largest telescope. It was dedicated in late 1996. This video shows the Visitor Center, the Frank N. Bash Visitor Center, where I'm located right now. We have a nice facility with a sundial courtyard out front, a large building with an area out behind, including an amphitheater and several telescopes. We are using the telescope tonight circled there in yellow. It's our 16 and 3-inch telescopes. These are also the telescopes that we're currently using for our star parties. We're providing camera views from these telescopes to visitors here on site. We're not directly looking through the telescopes at the star party at this time. So that's where I'm located. I also wanted to go over just a brief overview of the program tonight, as we do for all of our programs. We're doing the introduction now. I'm about to give you an introduction to tonight's southern sky. There's a lot going on out there tonight, as it turns out. Then we're going to proceed right into our telescopic views of the moon, a low power view to start out with to see the moon's major features, and then we'll segue into some high power views of the moon, showing us up close views of craters and mountain ranges and all kinds of cool stuff. Our discussion section tonight is not really, along the same lines as the discussion section that we've had in the past. We're going to mention again the International Observe the Moon Night from NASA coming up on this Saturday. And during that time, I will be realigning the telescope from the moon to the planet Jupiter. We're also going to look at the planets Jupiter and Saturn tonight. And then, as I mentioned earlier, toward the end of the program tonight, we will be taking a few of your questions from the moderators in the stream. The equipment we're using tonight is the same set of equipment that we always use here for this program. It's two telescopes, a 16-inch telescope, which gives us our high power views of the moon. And in fact, you can see that behind me right here. It's the black carbon fiber tube telescope. And then mounted on the side of the big one is a smaller telescope right here. That is our 3-inch telescope to give us low power views of the moon. And then if you look on the back of each of those telescopes, we have small cameras made by a company called Point Grey Research. And we have two different models of their cameras tonight that we're using for the low and the high power views of the moon. And finally, all of that telescope equipment rides along on something we call the mount. It's basically what allows it to move around and to track the moon and the planets and the stars during the time that the Earth is spinning, which is, pretty much all the time. But during our program tonight, that mount will keep our celestial objects centered in our field of view. All right, I did want to point out, I'm going to get my image out of the way there, that if you go outside tonight, maybe right after the program, it's not quite dark where I'm located right now, but it will be nice and dark afterwards, and it might be dark where you are right now. If you go out there and look toward the south, you're going to see the moon, of course. The moon tonight is in the constellation Sagittarius. And then over to the left, that is to the east of the moon, you should see two bright star-like objects, non-twinkling star-like objects. The brighter of the two is the planet Jupiter. The dimmer of the two, to the left of Jupiter, is the planet Saturn. Now, technically, this view right here is for 10 p.m. this evening from our location. The reason I have it set for 10 is because if you go out at 10 o'clock local time for you this evening, and instead of looking to the south, you look more over to the east, you'll see another bright object over there, which is the planet Mars. Mars is getting brighter and brighter to a peak brightness in about 3 weeks or so. It will be at its brightest point, and that's also around the time we're going to be doing our Planet Fest program. So tonight the moon is over to the west, that is to the right of Saturn and Jupiter. But tomorrow night, if you go outside, you'll notice that the moon is pretty close to the planet Jupiter. That's tomorrow night, September the 24th. The next night, September the 25th, the moon will be fairly close, about as close as it was to Jupiter the night before, but on the 25th, very close to the planet Saturn. So we have some nice moon and planetary conjunctions coming up in the southern sky over the next couple of nights. And then if we go some more nights into the future, now keep your eye on Mars over there and the moon. Moon moves around the Earth every day, so we see it shift position with respect to the background stars. And on October the 2nd, if you go outside on that night, you will see the moon very, very close to the planet Mars. Very nice planetary conjunction. And if you have just an ordinary pair of binoculars, that is a great tool for going out and seeing that conjunction. You'll be able to easily separate them with your eye. But in this case, for example, through a set of 10 by 50 binoculars, you'll not only more widely separate the moon and Mars, but you'll also be able to see some of the features, some of the larger craters and other features on the moon. So don't forget, October the 2nd, we have a nice moon and Mars conjunction. Try to go out and see that if you can. Okay, now we're going to transition over and give you a live view of the moon. Now, this is a live view of the moon that you're seeing right now. I need to check just one quick thing over here to make sure that our camera is ready to go. It's a little frozen, but that's okay. I'm going to bring it back for us. And I'm going to center that moon up a little better for us. Now you're going to see the moon moving. I also see some clouds moving. We do have some really, really thin clouds. They're probably not going to affect us at all, so I'm not worried. About an hour ago, though, I was a little bit worried because we had some pretty big clouds out here, but they have dissipated, giving us this beautiful view of the moon. Now, we call this a low power view or a wide view or a low magnification view because we're seeing the entire moon. This is the advantage of a pair of binoculars or a very small telescope working at low power, is that when you look at the moon with that equipment, you're seeing the entire moon. And I always like this view quite a bit. Now, I do want to show you some features on the moon. So I've got a little arrow I'm going to be moving around down here to point at various things. I first wanted you to notice that the moon is a half moon tonight, a phase that we call first quarter. We're going to come back and talk about that in a little more depth here in a minute. That describes the shape or the phase of the moon. Now look across the moon and you can notice, you can see with your eye, and certainly in this low power telescopic view, that there are big dark patches like this one up here. Let me see if I can make my mouse work a little better for us. There we go. That big one up there is called the Sea of Serenity. This one down here below it, south of it, southeast of it, that's a very famous sea called the Sea of Tranquility. Below that, more to the southeast, is the Sea of Fertility over here. Adjacent to both the Sea of Fertility and the Sea of Tranquility is the smaller one right here known as the Sea of Nectar. And then finally, one of my favorite seas is over here near the far eastern, northeastern part of the moon. It's called the Sea of Crises. Now, as we talk about during our moon programs, these seas, as we call them, are not bodies of water, but they were areas where lava once existed. After large impacts or just volcanism, lava welling up from below the moon's surface, filling impact basins and flowing out across the surface of the moon, going to the low points, filling them up, and solidifying into these seas, or mare, or maria, plural, that we see today as the dark patches on the moon that can make shapes to some people, like the man in the moon, the woman in the moon, the rabbit, all kinds of things that people see. So that is more fresh surface. There are fewer craters in those seas because they happened after most of the heavy cratering on the moon occurred. So it's only just the most recent cratering events, impacts, that have caused craters to form inside those seas. You can also see some of the larger craters on the moon, and in particular, notice where you are seeing those craters. Like when I look across the moon's surface, I'm not really seeing a lot of craters over here, kind of on the round side of the moon. I'm seeing a lot of them, though, along this line that we call the terminator. That is where the sun is rising, and so the sun along the terminator is coming in almost parallel to the surface of the moon, and so it accentuates, it really brings out, makes more visible those crater walls and the peaks, the mountain ranges and all that are just really beautiful when seen along the terminator. All right, I made some notes just to make sure I didn't forget to tell you guys anything. I think we've covered just about what we need to here. I want to go back to this concept of this being a first quarter moon tonight. And I want to show you something here that's kind of cool. I don't want to show you that. Actually, I want to go down here. There we go. Now this graphic has the sun over on the left side of the screen, the moon's orbit around the Earth, and the Earth itself. You can see there, they're pretty small. We're going to zoom in on them here in a minute. The Earth and the moon are shown over there to the right side of the screen along their orbit. Along the Earth's orbit around the sun is that line, that very slightly curved line. And then the green arrow indicates the direction of motion of the Earth in its motion around the sun. And there's something kind of cool, as it turns out, about first quarter. Now tonight the moon's distance is 232,833 miles. If you take the circumference of the Earth's orbit, in other words, everybody knows the 93 million mile distance from Earth to the sun. That's the radius of the orbit, more or less. If you take that number and multiply it by 2, that's the diameter of the Earth's orbit. If you multiply that by pi, 3.14159266535, I could keep going, but I won't. That number is the circumference, the number of miles around the Earth's orbit, all right? Now, it turns out that when we have a first quarter moon, the Earth, if you look up at the moon, I can see the moon right there right now. If you can see the moon from your location, that location that you see where the moon is right now is about where the Earth was 3.5 hours ago. Yeah, that's pretty amazing. Take the circumference of the Earth's orbit in miles. That's a lot of miles, but divide it by the length of time it takes us to cover that distance, which is 1 year. And that's where we get the Earth's orbital speed of about 67,500 miles per hour, which is about 3.5 times or so, or 3.5 times that is the distance from the Earth to the moon tonight. So look at the moon. I can see it right up there. That's where the Earth was about 3.5 hours ago. Now, I had a few other things I wanted to show you, but that don't directly apply to what we're talking about, but I'm also trying to keep track of my time tonight to keep us on time, and so I'm going to do a little skipping around here. So now what I want to do is go back to our live view of the moon for you, and I'm going to move the telescope to about the location. I'm going to turn on a crosshair. You can see that now. I'm going to move the telescope to about where we're going to start our first high power examination of the moon. Now you can see the moon moving again. Remember, that's not really the moon moving, it's just the telescope moving. I'm going to center up just below that nice pair of craters that you see over there. That's more or less where I want to go. I'm going to turn off that crosshair. Now I'm going to switch cameras on you. I think this view will stay visible, yeah, until I bring up the next view, which is going to be a high power view. Here we go. Wow, look at that. Now again, we do have some clouds, and I'm going to make a few adjustments to this image. That image, for some reason, looks somewhat odd. It probably shouldn't look like that. I'm going to try a few things here to clean up that image. And that does not look right. Tell you what, let me switch from monochrome to color and then back to monochrome. Sometimes that fixes it. Because I am seeing some clouds out there, but they're not really thick enough to be causing that much of an issue. All right, well, I think that's an improvement. I can't really tell, honestly. I'm looking at a screen here that's pretty dim. It doesn't completely accurately reflect the feed that you're getting. But nonetheless, we're going to go with what we have here. It's not quite what I wanted, but sometimes you just have to go with what you have. All right, I need to do just a little bit more centering here for us, so that we can see all the features I wanted to see tonight. There we go. That's pretty close. You can see those clouds. Now, I assure you, they're just pretty thin clouds, so I'm not too worried, but I can kick up the gain here, or rather the exposure time. Hopefully make that a little better. Okay, now what I want you to notice in this view are those two big craters near the top. These are some craters that we have visited before on our moon tours, and they are called Aristoteles on the top up there and Eudoxus down below Aristoteles. They're about the same size. Aristoteles is about 54 miles across, Eudoxus is about 42 miles across. And if you look slightly down below them and over to the left, to the west, let me get my pointer back on here for you guys. So here's Aristotle. No, that's not what I wanted to do. Sometimes this software is a little hard to adjust to. That is Aristoteles up there. This is Eudoxus. I wanted to direct your attention to this group of mountains right here. That is a group of mountains known as the Lunar Caucasus. This range extends up there about where Eudoxus is, the crater on the bottom of our pair here. That's more or less where the Caucasus Mountains start, and then they extend all the way down here to the south, a total length of about 275 miles for the Caucasus Mountains. They form the northeastern boundary of the Imbrium Basin, the Sea of Rains, which we're not actually able to see tonight. It's over to the left of our view here, over to the west. It's not in daylight yet. It will be in the coming days. But that is the northeastern boundary of that large impact basin, whereas the Caucasus Mountains also form the northwestern boundary of the Sea of Serenity. And we're looking at about half of the Sea of Serenity. Here's more or less the border, the kind of the northern, northeastern, and northwestern border over here of the Sea of Serenity. Let's see, what else is here I wanted to mention to you? Well, I did want to mention that if you were on an expedition here in the Caucasus Mountains and you wanted to go to the peaks, the tallest peaks in the Caucasus Mountains, that would be an elevation of about 20,000 feet. So not all that much below where Mount Everest would be relative to sea level here on planet Earth. About 20,000 feet. Still, 10,000 feet short of Everest, but still, reasonably close. We are still experiencing a little bit of cloud cover over there. Let's see. If I didn't mention this explicitly before, I wanted to make it clear to everybody that craters like Aristoteles and Eudoxus here are almost entirely impact craters. There are a few, very, very few craters on the moon that we think are caused by volcanism, not current, but past volcanism on the moon. But almost all of the craters that we see on the moon are formed by impacts, and most of those, almost all of those, formed a very, very long time ago. All right, well, we're getting some enhanced cloud cover, so everybody have pure thoughts out there. I don't know if that will help, but it certainly won't hurt because we are getting a little bit of cloud cover here. We're going to move on to our second field of view. So we're going to travel a little bit down to the south. There you can see pretty much the entire Sea of Serenity. I will brighten up that image for you here in just a moment. The clouds are not really helping with this. I sense that not all of you are having pure thoughts. I'm trying to make it better, trust me. All right, now it's going to look a little washed out because when we have to extend some of these settings, it does tend to wash out the view a little bit. That's at the expense of being able to see the moon at all. All right, regions in our field of view now that I wanted to point out would be, well, there's a fairly large crater to the upper right part of the view, and I do realize it's fading out again. Now, I do have a backup like we had during at least our last moon tour, maybe the last two moon tours. We had to transition over to a computer generated from real data view. And I think I'm going to go ahead and do that at this time because we don't know when that's going to come back. So let me get that image up here for you. I do need to do a few little gymnastic sort of things here. Now, what I'm going to attempt to do here is not that, but center up the view that I wanted to show you from our live view, and I'll keep an eye on the moon. I can actually see it out there, so I'll bring it back here in just a minute. All right, now look at that crater near the top right part of the view. That is a crater called Posidonius. Posidonius is about 60 miles wide, and it's not really that impressive as craters go, but I wanted you to look carefully. Notice that it's essentially just a rim, just the wall of the crater that's left because it was flooded with lavas. It was once a much deeper crater, but was then later filled in with lava. And so all that sticks up really is the rim. But look carefully. And I guess now that we're in sort of a digital view, I could even zoom this up a little for you. This is an interesting crater because it's sort of like a crater within a crater. Let me show you what I'm talking about here. So you've got the rim of Posidonius. Remember, that's about 60 miles across here. But inside of it is the rim of another crater. It's like a crater in a crater, both flooded, and in both cases, just the rim of the inner crater, which, as far as I know, does not have a name, and the outer rim of Posidonia sticking up there. So that's kind of cool, I think. Moon is still behind a cloud, so we're going to go back over, stay with our virtual view for now. Now, if you want to get an image of the moon that very essentially perfectly reproduces how it's going to look tonight or at any time, you can go to the link that you see at the bottom of the window where it says from the NASA Scientific Visualization Studio. That link, if you follow that link, that will take you to a site where you put in the time and date, and you'll get an exact reproduction of how the moon will appear on that evening, and you can zoom in and look at all kinds of cool features. Now, the Sea of Serenity that we're seeing here, essentially almost all the view, the big, wide, flat floor of the Sea of Serenity, the entire Sea of Serenity is about 439 miles across, so quite large, roughly half the size of the state of Texas. The Sea of Serenity is located in an impact basin. That's where a very large impact occurred billions and billions of years ago. And below that sea, below the Sea of Serenity, is what's known as a mass concentration or a masscon, a mass of, well, we don't know exactly what it's a mass of, but we know it's a higher density material, and it was first discovered by its gravitational effect on a spacecraft called the Lunar Orbiter that was orbiting around the moon in 1968, taking high resolution images of the moon in preparation for the Apollo moon landings. So, Sea of Serenity. This little crater that you see near the middle of the view, let me point at that for you right here. This little crater is called Bessel. And Bessel is not all that impressive. It's small. It's about 9 miles across or so. What's kind of cool about Bessel, and you can certainly see it very well here in the LRO image, is this wispy line, this line that we call a crater ray. Large craters, when they form, are not necessarily just large craters, but any crater, when the asteroid comes down and hits the moon, it splashes stuff out in all directions. Where that stuff comes down and lands forms lines of debris that point back from all directions to that point of impact. And those bright, wispy materials are called rays. And now those don't last forever. They last about 1 billion years until they're eroded by solar radiation and micrometeorite impacts, but they do persist. And there's a crater we've looked at before called Tycho. And now this ray, some sources I read said that is a ray from the crater Tycho, which is hundreds and hundreds of miles away from this location. Some sources I looked at said that they didn't think it was a ray from Tycho, but it is sort of interesting that whosever ray this is, from hundreds of miles away, it's not Bessel's ray, but Bessel sits right in the middle of that wispy ray structure. Let's see here. Oh, one of my favorite mountain ranges. I want to show you that. We can't see much of it right now. So here, get my pointer back on here. Remember, these are the Caucasus Mountains up here. This range, which starts about here and goes south and bends back over to the west, they're not quite in full sunlight tonight, of course. But this part right here is just the northernmost part of the Apennine Mountain Range. And Apollo 15 landed in the Apennine Mountains, just on the other side over here. In fact, that little dot right there, that little bright dot, I'm pretty sure is actually the summit of Mount Hadley, which is just to the north of the Apollo 15 landing site. That is the summit of Mount Hadley sticking up just enough to catch the morning sunlight rays. And so the view of that part of the moon will dramatically change over the next day or so, as from their perspective, the moon rises higher and higher. Okay, let me get the arrow off because I'm now going to show you one more thing in this view before we go on to another region. Centered in this view, and specifically right about in here, is the landing site of Apollo 17, the final Apollo crew. 1972 landed there, Apollo 17, in what's known as the Taurus-Littrow Valley. It's called the Taurus-Littrow Valley because this crater right up here, fairly large crater just north of their location, is Littrow Crater, and the lunar module's name was the Taurus. You know how Apollo 11 had the Eagle? Well, Apollo 17 had the Taurus, and so the Taurus landed right down here in what has become known as the Taurus-Littrow Valley. And now I have some cool slides I want to show you that relate to the Apollo 17 mission. Get my picture out of the way here. Three-person crew on all the Apollo missions, two of whom got to go down and walk. We'll see them in a minute. And one of whom had to stay up in the command module and take care of business up there while the other two walked on the surface. The crew of Apollo 17 were Gene Cernan, the commander, Harrison Schmitt, the lunar module pilot, and Ronald Evans, who was the command module pilot. Now, not known to a lot of people, there were 5 more creatures well, they didn't land on the moon. They ended up orbiting the moon along with Ronald Evans. Their names were Phi, Phi, Fo, Fum, and Fui, and they were lab mice. And I couldn't find any direct information about what was being studied about these mice, other than perhaps the effect of zero G. And I don't know if any other mice went to the moon, but not a lot of folks know that some mice did go to the moon, at least on the Apollo 17 mission. The moonwalkers on this mission were Gene Cernan and Harrison Schmitt. Harrison Schmitt has the distinction of being the only scientist to ever walk on the moon. He was a geologist. He's a geology professor, and it was important for him to be along on the mission because, well, who knows better than a geologist what an interesting rock on the moon might look like. Other astronauts receive training in geology so that they would have a basic knowledge of good things to look for, to pick up, to bring back. But Harrison Schmitt was the only scientist who went to the moon and walked during the Apollo missions. They got out and walked around. They spent 75 hours on the moon. They did 3 different extravehicular activities, or EVAs, during that was a total of 244 pounds of rock and soil samples that they brought back. Now, in that picture there, next to that gigantic boulder, that is Harrison Schmitt. And on the right there, you see Gene Cernan next to the lunar rover and the American flag, and some of the mountains right around the Taurus-Littrow Valley where they landed. Now, they left that lunar rover on the moon. Of course, they didn't bring it back to the Earth, but where you see it in that picture on the right is where they left it. They weren't like, collecting rocks around the rover there and then drove home, and they left it there. And that picture on the left is from the Lunar Reconnaissance Orbiter, much later, taken decades later. You can go to that website. We've talked about this on the moon tours before. But the Lunar Reconnaissance Orbiter orbits at low altitude above the moon. It's a satellite orbiting the moon. And it has such high resolution cameras that it can actually see where they landed on the moon. So you can see the descent vehicle. You can see where they drove around the tracks and where they left the LRV, the Lunar Roving Vehicle, and which traveled on that mission about 22 miles or so. So that's pretty cool, I think. All right, let's go back to, well, let's see if we have a live view. Ooh, hey, tell you what, I think we're going to stick with the great view, but not live view, because we still have quite a bit of cloud cover over there. And so now what I want to do is move on to our next field of view. So give me just a moment to center us up here. We're going to travel southward. And let's see, we need to zoom in a bit. I'm trying to make this match what the live view would have matched if we had a live view right now. So that's actually pretty close enough for state government work. All right, features in this view I wanted to point out. Well, that big dark expanse of lava flow that you see there is the Sea of Tranquility. That's probably the most famous sea on the moon, certainly the one that most people remember, simply because it's the first landing site, and we'll talk about that in a minute. The first human landing occurred near the southern shore of the Sea of Tranquility. Now, unlike the Sea of Serenity, the Sea of Tranquility does not contain a mass concentration below it. And so if mass concentrations do tend to be things like large masses of lava, well, there's not one below the Sea of Tranquility, or solidified lava, basaltic lava type, or rocks, basically. So there's not one of those below the Sea of Tranquility. So it does not exist in a impact basin that existed there before the lavas erupted onto the surface. The Sea of Tranquility itself is, let me check my resource here. I think it's about 543 miles. Let me bring my image back so y'all can see me here, not that that's much to look at. 543 miles across the Sea of Tranquility. Let's see, Julius Caesar is a crater I wanted to show you. It's kind of over on the left side of the view. It's, again, a flooded crater, mostly just the rim. The northeastern, western, southern, but intruded into by lava, so it's basically full of lava here. What I wanted to show you really is below, down south of Julius Caesar crater, and you probably already spotted it, this long linear feature right here. That is a feature known as a rill. Now this one is known as Rima Aurea Deus. Rima Aurea Deus. In this case, what happened, we think, is that there were two parallel fault lines on either side of that structure, and the crust sank, collapsed between those two parallel fault lines and produced this feature that we call Rima Aurea Deus. Now, when that sort of thing happens, when you have two parallel faults and the crust between them sort of falls down and creates this U-shaped channel, that in geological terms is known as a graben. Now, notice not only the rill in this case, but there's a little crater right down here just south of the rill. I want to go back to our moon slides, and I wanted to show you, this is what I skipped over earlier, but I wanted to show you this just because it's really cool. This is a picture that was taken during the Apollo 10 mission. That they didn't land on the surface, but they traveled to the moon and orbited the moon and took pictures before Apollo 11 landed some months later. They took a beautiful image here of Rima Aurea Deus, which is this long, long linear feature that you see. And then this crater, which now in this view appears quite large, is a crater called Silberschlag. Silberschlag. And if we go back to our view of the moon, you can see that little crater I pointed out. There's Silberschlag right there directly below Rima Aurea Deus. Now the rill runs almost 200 miles across the moon's surface and terminates over here in the Sea of Tranquility. I'm trying to keep an eye out the opening of the dome here so that I can see if Jupiter or Saturn are visible, but I can't see them either because I can't see far enough to the west or the east, excuse me, or they're just clouds in the way. So let me show you a few more things in this view. If we move down a little bit and kind of over to the east a little bit, there's a pair of craters that I wanted to point out. And they're not, like fascinating or anything, but this is Ritter crater. It's 18 miles across. This is Sabine crater, all about 18 miles across as well, a little bit smaller. Like I said, they're not all that impressive, but remember Ritter and Sabine, and then this little tiny crater right here that is known as Moltke. Moltke, M-O-L-T-K-E, Moltke. And Moltke and Sabine and Ritter are your starting point for locating the Apollo 11 landing site, which is about a third of the way from Moltke crater to Sabine crater and slightly north of that line. So right at the tip of that arrow that you're now seeing, that is the Apollo 11 landing site. And just like we did earlier, I want to show you some cool stuff from the Apollo 11 mission. Of course, most people remember the crew of Apollo 11 since they were the first. Neil Armstrong, the commander, Edwin Buzz Aldrin, the lunar module pilot, and Michael Collins, the command module pilot. And of course, on that crew, it was Neil Armstrong, who first touched down on the moon. That's one small step for a man, one giant leap for mankind. He stepped first, and shortly afterwards, Edwin Buzz Aldrin took a step out onto the moon's surface. They conducted EVA, I was going to say EVAs, actually they only conducted one EVA. They were trying to play it pretty safe, on these early missions. And so they only did one EVA, but it was fairly long, 2.5 hours, on which they collected about 48 pounds of lunar rocks and soil. Now the picture on the right is an often seen picture. That is Buzz Aldrin saluting the American flag after they landed. The picture on the left is a rare picture of Neil Armstrong on the lunar surface. Almost all of the pictures taken on that mission on the moon's surface were taken by Neil Armstrong. It's sort of like when I would go home for Christmas or Thanksgiving and pictures were being taken, I'm not a huge fan of having my picture taken, which is sort of odd given that I'm doing this program. But I always was behind the camera, and so on the Apollo mission, Neil Armstrong was apparently the camera shy one. He was the one taking most of the pictures, and so most of the pictures showing an astronaut on the surface of Apollo 11 were actually pictures of Buzz Aldrin. Now, when they came back from the moon, along with Apollo 12 and 14, when they came back from the moon, these early missions, when they got back, they had to quarantine. Now, we can all sort of relate to that these days. Apollo 11, 12, and 14 crews had to quarantine because we did not know for sure that there were no living organisms on the moon. And, if there were lunar microbes, well, you probably don't want to bring those back to Earth, so they had to quarantine for a while. And, if I had been to the moon recently and if I'd been in quarantine for 3 weeks, what would I want to do when I got out? Well, I'd want to have a big party. And that is actually what happened. A few cities across the US were hosting ticker tape parades, this one in New York City, for the Apollo 11 crew when they got back to the Earth safely and got out of quarantine. So I wish for all of you, once all of this pandemic stuff ends, that we can have a party that's at least along the same scale maybe as something that they would have done for the Apollo crew when they got back from the moon. Okay, and we've already been to that. So let's go back and see if we have a live view of the moon. We do, actually. It's not perfect, but we're gonna stick with it. So now this is back to our live moon image. It is apparently frozen. The camera is, so I'm going to bring it back for you and see if we can make that look a little better. Hey, that's pretty cool. I think these are the best views of the moon we've had all night, folks. All right, well, what we're going to do now is proceed on down to our final field of view. We are running a little behind time, so I'm just going to point out a few things in this last view of the moon before we move on, and I'll take a peek before we quit looking at the moon so that we can peek and make sure that Jupiter and or Saturn are visible over there. I'm going to go a little faster here. There we go. I need to center up our final view, and I see the starting point of where I want to be. Now that image is looking sort of weird again, and I'm really not sure why. Of course, this was all perfect, right before we went live. All right, well, we're going to stick with it. This is more or less the part of the moon that I wanted to show you. We need to go just a little further south here. All right. So this is, I think, our final view of the moon tonight before we move on to Jupiter and Saturn. We have a trio of craters that we have visited before on our live moon tours. Let me show you well, it's pretty obvious where we're looking here, but these three craters, which are Theophilus, Cyrillus, and Caterina crater. They're about the same size. Theophilus up here, 68 miles across. Cyrillus is 61 miles across. Caterina is 65 miles across. And they are along the northwestern border of a large circular structure known as the Sea of Nectar. That's one of the most ancient impact basins on the moon. The impact basin part of it actually extends all the way out to Altai Scarp over here, the outermost ring of sort of that original crater, if you want to think of it that way, when that impact occurred. But now, as we pointed out before, you can see in the middle of Theophilus, there's a central peak. These form as the result of an uplift or rebound of the rocks directly following the impact of the asteroid that formed the crater in the first place. I've always liked the one in the middle of Cyrillus crater here because it's almost sort of a twin peak, really. Imagine you had a lawn chair sitting out on top of the twin peak of Cyrillus crater, maybe a good place, good time to have a beer. But it's really nice in that it has a twin peaked central uplift there in the center. And then down here below, the oldest of the three craters is Caterina crater, and now we are getting quite a bit of cloud cover again. So I'll tell you what I'm going to do here is leave you with this view. I'm going to turn off my picture and I'm going to mute my mic for just a minute. I have to check to see if Jupiter and Saturn are over there. So hold on just a sec. Okay, good news. Good news, everybody. We have Jupiter and Saturn, maybe not in a completely clear sky, but in a clear enough clear sky that I think we can get them. And so now the telescope is going to have to do some gymnastics while it goes and finds Jupiter. And I'm not exactly sure the degree to which the gymnastics are going to happen here. So I'm going to shut down our view. Tell you what, I'm thinking of something here interesting to show you that will sort of fill up some time. Yeah, International Observe the Moon Night coming up this Saturday. You folks enjoy that for a minute. I'm going to stay on the mic here with you, but I'm now going to point the telescope, tell it to go over to, in this case, the planet Jupiter. Now we're using a computer-controlled telescope. Jupiter, is not hard to find, nor is the moon, but this is just the most efficient way of getting there. And it is going to take the long way, so I'm going to leave you for a moment. Otherwise, some cables are about to be pulled out. Okay, everybody, I'm hoping that we are now more or less aimed at the planet Jupiter. I'm going to have to go take a look at it here in my software. Give me just a moment. In the chat, while I'm getting Jupiter centered up here, tell me your favorite thing about the planet Jupiter. Let's see what we have. Well, I see Jupiter. Now, I should have said earlier, I'm saying it now, the views of Jupiter and Saturn in our telescope tonight are going to be a bit on the small side. Certainly for the first view. I want to show you the moons here coming up in the first view. That requires kind of a wide field of view because they're traveling much further in their orbits around Jupiter than Jupiter is in size. Okay, we're almost there. Now, initially, I'm going to show you just the planet, and it is going to be quite small. So here it comes. That dot that you see in the middle of the view there is the planet Jupiter. Jupiter, of course, is the largest planet in our solar system. It's about 11 times the size of the Earth. You could take all the rest of the planets in our solar system and stuff them inside of Jupiter and still have a lot of room left over. We're going to see it more up close here in just a minute. But first, I wanted to show you the moons. And this is possible because we can take the exposure and ramp it way, way up. The thing about a camera is that it can't accommodate a wide range of brightness like our eyes can. It has a not as high a dynamic range, we would say. Now, in the center is the planet Jupiter. On one side, on the left, you can see a little dot. That's one of the moons. And then on the right side, you can see two more dots. Those are two more of the moons of Jupiter. So I just wanted to show you this low power view to kind of fit the moons in there quite well. We might see one or more of them in this next view I'm about to show you as well. So let me switch telescopes here and get us a higher power view of Jupiter. Hopefully it will be relatively centered so that we can spot it easily. And I'm not really seeing it in the view here. I was concerned that the two telescopes, they can get a little bit out of alignment when you move the whole telescope. One will kind of sag with respect to the other one. So they're not precisely aimed to the same part of the sky. And that is what has happened here. And I don't know that I'm going to be able to get them back centered. Let me think about that for a minute. In the meantime, I did want to show you a few things here. A scale drawing of the planets in our solar system, Jupiter being the largest, of course, followed closely by Saturn, Uranus, and Neptune there in blue, and then the tiny terrestrial planets, Venus and Mars and Earth and Mercury. So look at the size of the Earth there compared to Jupiter. Very, very, very tiny for the Earth. As of 8 o'clock tonight, when we started our program, Jupiter is at a distance of about 443 million miles. Its diameter, as we said, about 11 times the Earth's size. Mass about 320 times the Earth's mass. That's sort of like weight, so essentially weighs as much as 318 Earths. Goes around the sun in about 12 years, rotates on its axis very, very rapidly, 9 hours and 54 minutes, and is almost entirely made of the two lightest elements, hydrogen and helium. It comes in second in terms of the number of moons, second to Saturn. Jupiter has 79 moons. Now, Galileo observed the planet Jupiter back in January of 1610. He also discovered what we now call the Galilean satellites of Jupiter, the three of which we have seen in that last live view. He charted them as they moved around the planet. You can see some of his original logbook there. And then the Voyager spacecraft, when it flew by in 1979, took pictures of all four and more of those moons, but the four main ones you see there. And the arrangement we have tonight, I think that Io actually is still in the shadow of Jupiter, and that's why we only saw three instead of two. But we saw Callisto Ganymede on one side, a little more widely spaced out, and then Europa all by itself on the other side. I, so far, have been unsuccessful in getting our high-power telescope centered on the planet Jupiter. So I'm going to try one last-ditch attempt here. This is sort of like, if this doesn't work, nothing will. See if we can get it centered up, because I really would like to see an up-close view of Jupiter. I don't have the view up because it's just black. It would just be black for you right now, so you're not really missing anything. Let me go back to its known position first. I'm hunting around with the telescope to see if I can find it. And I don't think it's going to happen, folks. All right, so what we're going to do at this point is we're going to move on to Saturn. I'm going to see if I can get Saturn. Again, it's going to be very tiny in the field of view, but I do want to see if we can get this centered here and at least get a small view of the planet Saturn for you. Telescope is now moving over there, and I'm going to switch cameras as we did before. Bring up our low power view. And there's the planet Saturn. Let me get it centered up for you, and I'll bring it over for you. Now again, it is going to be very, 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 very tiny in this telescope, but it is unmistakable as Saturn. So here we go. Here comes a live view. That is Saturn right there in the middle. Now we can do a digital zoom. That's not the preferred way of doing this, but I want to see if that improves it at all. Yeah, somewhat. Let's try 200%. Now, as I said, this is not, oh, you can't see that, can you? Let me back out one level here in our digital zoom. It's not the best view ever of Saturn, but it's there. I can see the planet, I can see the rings. If we increase the exposure time, we might be able to make out at least the largest and brightest moon of Saturn. Let's try to increase that exposure time up a bit. I'm thinking that now some of what you're seeing, some of those white dots, actually most of those white dots in the picture that you're seeing there are noise on the chip, but I'm thinking that that little dot right there is actually the moon Titan, the largest moon of Saturn, the second largest moon in the solar system. The only moon that has a thick atmosphere, I think that actually is the moon Titan. Now let me bring that brightness down a little bit so that it's not so washed out. That is the planet Saturn. Now do, folks, stay tuned for our Planet Fest. I didn't really have a chance to test this out much at all before doing it live tonight, but we'll have this all resolved for a Planet Fest coming up in about a month or so, a little less than a month. Okay, well, let's see, on time, we've got just a few minutes before the end of our 1 hour program. So at this point, I want to transition over, and I know that says live, that just occurred to me, it says live moon image. That's a live Saturn image. I'll transition over here and see if we have any questions. Let's see. One of my moderators tells me that the few clouds are coming in. Yeah, I figured that out. Let's see. Stephen Wilson says, please comment about the discovery of water at the floor of polar craters. Thanks. Oh, you were a Clementine crew member, were you? That's pretty cool. Yeah, not so much water, but ice. We had hints for years and years and years that there was ice at the floor of some craters near the moon's poles, especially near the southern pole of the moon, where a crater near the South Pole has a rim around it. And because it's at the South Pole, sunlight can never get down into that crater and melt any ice. And now we're not sure how the ice got there, but we do now know that there is some amount of ice that exists on the floor of some of these polar craters. And this was the Clementine mission helped to firm that up, the L-Cross mission as well, several spacecraft really ultimately required to pin down where we're seeing most of the evidence of ice near the polar craters, especially in the south. But yeah, definitely that could be a resource when we go back to the moon. Let's see. Miles Groff says, what resource would you recommend for finding the names of all craters and highlights on the moon? If you go to the LRO website, and I don't remember the address right off the top of my head, but if you do a search on LRO, Lunar Reconnaissance Orbiter, you'll go to their website. You want to look at their quick map. It's a way of taking LRO data and mapping it onto the surface of a sphere. And if you go to that quick map view, you can turn on layers in that digital view, one of which is called nomenclature. And that will give you names of craters and mountain ranges and individual mountains and seas and where people landed on the moon. That's probably the really coolest resource I can think of for learning about names of or identifying things on the moon, basically. We have time for one last question before our program ends tonight. Amiya Gupta, I hope I'm pronouncing your name correctly. Amiya might be Amaya. Let's see, Kevin, if you could pick an area of the moon for a scenic hike, where would you go? Oh my goodness. Well, I would probably go one of two places. I would either go near the Apollo 15 or 17 landing site. I mean, I'd pretty much have to make a stop off at Apollo 11 just because that's the first time humans did anything like that, and it's just a huge historic event. But just in terms of scenery, I live in the mountains out here. I really appreciate mountains, and so I think I would go to the Apollo 15 landing site in the Apennine Mountains, or the Apollo 17 landing site in the Taurus Littrow Valley area. Yeah, I think one of those two sites, maybe hike up to one of those peaks, and lower gravity might compensate for my advanced age. If I'm going to hike to the top of a lunar mountain that's 15, 20,000 feet tall, I can't think of a better view really than that, other than the view of in orbit, orbiting the moon, looking down at the moon, and being able to see all those features sort of that we've all seen. I've seen, many of you have seen through telescopes, see it live from lunar orbit. So yeah, I will never get the chance to do that, but I hope some of you watching tonight do in fact have the chance to do that. All right, well, we need to wrap up our program tonight. Again, I wanted to thank all of you for being part of it, and I wanted to apologize for not having very good views of the planets. We did, of course, want to concentrate more on the moon as we typically do, but since Jupiter and Saturn were nearby, we thought we'd throw those in. But we will improve the situation quite a bit for our Planet Fest coming in October, so be on the lookout for that. And if you Would like to keep an eye on our social media outlets. We do post updates there for things like our adding of capacity for our Star Party programs, the opening up of our daytime guided tours. That should be happening fairly soon. And so do keep an eye on that. And I hope to see some of you here on site in the future. And again, thank you for joining us tonight. And we will see you again on our Planet Fest program in about a month or so. Good evening, everybody.